Hello, this is a demonstration on how I use my laptop as a acting monitor for the Raspberry Pi that I'm using in my project. I'm going to be using two types of software. I'm going to be using PuTTY, which is an implementation of SSH, and I'm also going to be using VNC Viewer, which will allow me to display what the Raspberry Pi is outputting onto the laptop. First of all, I need to start up the SSH service on the Raspberry Pi before I can PuTTY into it, or SSH into it from the laptop. I've connected the Raspberry Pi to my main monitor so that I can do that. To check if it's on or not, you just use the command service SSH status. And as you can see, the status of that activity is inactive, so it's not on. What we want to do is sudo service SSH start. And then we can check the service again, and it says that it's running now. So now we can go into the software on the laptop to enter this. The problem I had before was I was using power from the wall, so when I would turn it off, the SSH service would automatically shut off and I'd have to turn it on again. To counteract that problem I had, I'm always just having the power coming from the laptop, so that all I need to do to change this to my laptop is to unplug the display and my peripheral inputs like my keyboard and my mouse while the power is still on. This will ensure that when I plug the Ethernet for the display into the Raspberry Pi, that the SSH service will not turn off. So now that the SSH service is running, we can use the software PuTTY on the laptop. So all I've done is I've connected an Ethernet cable from the laptop into the Raspberry Pi and taken out the peripherals from the Raspberry Pi. So it's still displaying what the Raspberry Pi is doing, which will be a good demonstration in a brief moment. Now we use PuTTY, and it will prompt you to enter an IP address or hostname. In this case, we're using a local connection for the Raspberry Pi with the Ethernet, so all we need to type in is Raspberry Pi.local, and it needs to be an SSH and port 22, and then we just click done. And this will have a terminal, which is actually the Raspberry Pi's terminal, so we're going to log in as Pi with our password. And now we are actually in the terminal of the Raspberry Pi. And look at the directories and stuff. So we have all the directories in the Raspberry Pi. And we can also check the SSH service and see if it's still running as well by just doing service SSH status. And as you can see, it's still running. So now we're going to use a VNC viewer to actually see the display of the Raspberry Pi instead of just the terminal. Like before, all we're going to supply it with is the Raspberry Pi .local. Click enter, and it's just going to connect to it. So our username is Pi, and that's our password. Enter. And then here we are. This is the display of the Raspberry Pi. So you can actually see that the changes I make on this screen happen on that screen. So what we can actually do now is disconnect the screen. So we've disconnected the display to the main monitor. So now this Raspberry Pi is connected to the laptop completely portably and can be taken outside, used for the capturing device's purpose. So now the Raspberry Pi is connected to the laptop, I'm going to demonstrate how the software Raspberry Pi TX is able to emit radio frequencies from the Raspberry Pi. To demonstrate this, I'm going to use AirSpy, the same software I used in the Arduino demonstration, to show that it is emitting radio frequencies. So, as an acting antenna, all you do is you take a wire and you stick it into GPIO4. Is this one right here? This will actually be inevitably soldered onto the device here, which is the low pass filter, which means that so only between 400 and 470 megahertz can be emitted from this, and this will be the emitter. So now we need to test the RPITX software, which is in the Raspberry Pi's directory, which I've downloaded, which is right there, RPITX. So we go into that directory. And we're going to be using this easytest.sh. So just go. And it will ask us which default frequency we want to transmit on. And we will be transmitting on 433, but just for demonstration purposes, we'll keep it the same as for 434. It now shows us different types of tests we want to do. So there's one called chirp, which when you select it, let me just start up the capturing device. We're currently at 433. We want to be 434, there we are. So when we enter chirp, you can see very small, just because obviously it's not connected to the proper transmitter yet. But you can see down here that it's doing a very small sort of chirping emission. If we go and cancel that, then it stops. There's spectrum, which is supposed to produce an image in radio frequencies, but it doesn't look too amazing. But you can see that there's some sort of pattern that's going on here, and that does it for just a brief moment and then turns off. Our RF My Face, which is a webcam. I don't have a webcam on the Raspberry Pi, so it just does the same as the image one. There's a bunch of different tests, but they're not very important for my actual project. This is just to test that the radio frequencies are being emitted. So the easy test application was just to demonstrate that the Raspberry Pi can emit radio frequencies from its GPIO4 pin. What I'll be using in my project is the application RTL menu. Sorry. And so this prompts for an input frequency. This app basically is the app that captures and records the frequencies we want. So I've plugged in the SDR, which will capture the signals via the antenna, and let's just say we'll capture 434, and we always want the gain to be max, because that's for what the outputting of the recorded frequencies, which is to output 434. So we have different functions here, like record and play and transponder. All we really want to do is record. I don't have car keys on me at the moment, but essentially you'd record, it's running, stop that. So that's recorded essentially this. So if we were to play it back, you can see a short spike go up and down, and that's because I wasn't recording for very long and there wasn't anything that was going on, like a key fob going off or something. But that's a demonstration on how my Raspberry Pi connects to the laptop and how the software emits radio frequencies via the GPIO pin.